So things I would like you to remember before you attempt to take the next quiz. Essentially, everything we're talking about here today is related. All the syntax, all the terminology is related to the quiz. The quiz isn't due until a couple of weeks from now. So you should, like I said, to eliminate the stress, you need to be able to practice a little bit every day, and you'll realize that that you learn and you can remember more things. And I want all of you to get good grades. Now, if you somehow got not such a good grade so far on the first quiz, then email me and I can reset it for you so you can retake it. But with the second quiz, most definitely I would advise that you spend significant amount of time, and don't, even if it's like past due, don't take it if you don't feel that you are still uncomfortable with it. So we will keep talking about this week and next week, and I'll definitely try using quiz in class, hopefully today as well. So things to remember. Let me clean up a little bit here and just go back to this basic outline, right? So things to remember. Number one, we said that literal strings like this hello string return back an address of the first character, okay? That's something to remember. If you want to remember that character, say, today is a good day. All right. And then if you want to remember the address of the first character and use it someplace or in multiple places, like for instance, if I wanted to say that this was some kind of message, and if I wanted to display this message multiple times, I could have used it like this: std cout display message, a message like that. I can embed the new line in that message and just use semicolon. And I could like print this message multiple times, right? So in order to create such variable that holds the address of these characters, it has to be declared as a pointer, which is asterisk, pointer to a character. So overall, what this message remembers is two things, right? One thing that it remembers is the first thing that this pointer to character remembers is that message, right? It's a pointer to someplace there is a sequence of characters in memory, right? So it remembers where the first character is. That's number one. Number two, this pointer, and oftentimes it's actually on diagrams, you will often see that it's on diagrams, pointers are usually displayed like this, with like, just being a pointer with an arrow sticking out like that. All right. So besides remembering the address of the first character in that character string, the pointer message also remembers the second thing. I can draw like a second box around it. The second thing that it knows is the size of an object that it's pointing to, right? So it knows this is the size, this is how big that object is in memory. Because if this was pointer to an integer, like let's demonstrate that. Right? So if I had pointer to an integer, and I can put it here, integer pointer to an integer, ptr equals x, and x is another integer x, right? Well, first of all, this is perhaps the second thing to remember, is that you cannot just simply say x equals ptr because they're of different types. If you think about it, ptr is int asterisk, or pointer to an integer, and x is a plain int, right? To be able to to convert this int to a pointer to an int or address of int, you simply have to say, what's your address, right? What is your address? So you can say x, what is your address, and that's the ampersand sign, and it converts an integer, which x is an integer, right? It converts it to a pointer to an integer. And this way, everything looks fine, and you can do your assignment, right? But if we had someplace else in memory this variable x, right? Variable x, it's actually like 4 bytes in memory because integers are multi-byte objects in memory, right? So this PTR obviously stores the address of x in memory, number one, but number two, what also PTR knows, it's the second box around it, it knows how big this thing is. It actually knows that it's actually 4 bytes in size, right? So that's why you don't just create a pointer like that. PTR is a pointer. Compiler has to know pointer to what kind of object. Okay, this one is pointer to an integer. PTR is a pointer to an integer. Okay, message here is a pointer to a character. And so remember that int asterisk or int pointer is the data type. Just like int, there is also int asterisk. Just like character, there is also character asterisk. And those pointer types are designed to store addresses of objects. Okay, so I want you to remember this. What else I want you to remember is that when you use address in this context like message, cout will display the entire string, but if I wanted to display just a single character, well, let me just eliminate those extra lines. If I wanted to display a single character, I could have set index, right? I could have specified what that number is. Could be 0, could be 2, could be 4, could be 10, and so forth. And of course, if this index is out of range, so there is no such character in this character string, then of course I have a serious problem. The program may crash or it may not crash, and it may actually crash on the most embarrassing moment when you're demonstrating your program, right? So pointers do come with responsibility that we need to keep track of. How we're doing, how we using them to access memory, and we have to be careful about this. All right, so let's just say that if I wanted to, for the safety's sake, if I wanted to display just one character, I can say message 0, right? But at the same time, doing this or this is exactly the same thing. Using asterisk in front of pointer that's already declared, like this, is called a dereference operator or an indirection operator. And what it does exactly this thing. It just basically says, go to this address that you already have and essentially retrieve an object that you're pointing to. Message is pointing to characters. Right? So chart data type is the data type of object in memory to which message is pointing to by storing the address of that object. Okay, so these are exactly equivalent. And if I wanted to do something like this, x equals 1,000, for instance, right? If I wanted to do this assignment, I could have said asterisk pointer equals 1,000, and those two lines are pretty much the same, right? Because pointer PTR contains the address of x, right? And once it contains the address of x, if you dereference that pointer, you're telling the compiler, go to that memory address and go ahead and store this brand new value 1,000 in that memory location. Again, if somehow pointer is not dereferenceable, which means it contains an invalid address, the address which would be dangerous to use, then that line would be a pretty problematic line. And that's why programming languages like Java remove pointers from programming language, so that essentially problems are solved for you by the programming language itself. And we have yet to discover and compare how is it done in Java. But to finalize this segment, you can make pointer non-dereferences by saying null PTR. As you can see, null PTR is highlighted just like other keywords. Null PTR is a keyword, and this keyword pretty much creates a pointer PTR and initializes every single bit of PTR to 0. And we already said that address 0 is not a valid address in C and C++ world, and therefore we can use a 0 pointer or null pointer like this to indicate invalid value for that pointer. So obviously saying dereference PTR, dereference PTR here would be very dangerous, right? So instead, it's possible to say PTR equals address of X, and basically initialize it before using it. So this time you're specifying a new address, and of course this time I'm not using asterisk in front of pointer because I'm saying I'm actually modifying the address that the pointer should accept. I'm asking X, what's your address? And I'm storing that address inside that pointer, and now this pointer is ready to be used, and of course we can start using it. Now again, you should probably notice that this is just a sort of like a syntax demonstration, this entire demo, simply because it's probably very impractical. If you created variable X, you'd probably be using variable X and not even think about pointer. But remember, if somehow you need to be able to modify that X outside of this function, or provide its value outside of this function, you probably need a function such as, I don't know, void set equal 1000. However silly that is, but it can take integer. It can take integer pointer PTR again, right? And we can provide the body of this function, and we basically can say dereference PTR equals 1000. That's kind of silly function to have, but instead of doing all of this, I could have simply said, call this function set equal 1000, and specify address of my variable X to say that's the one that I want to modify. Now, while this still seems pretty impractical, because come on, all I have to do is pretty much this, right? It doesn't make sense in this context at all. Just use normal variable initialization. But remember, we're trying to understand those indirect memory access facilities, because they're going to be extremely helpful to us when we manipulate actual objects and discuss objects. So then it will look much more practical. And some facilities in the language, as you will discover, are available only when you use pointers, like, for instance, virtual functions in C++. So that's still far ahead of us, like week 12, 13. We're going to discuss those types of facilities. But for now, just realize that you can create any variable like X and pass it to any other portion of your program and have indirect access to that original object by passing its address, right? So notice that I do pass the address of X to this function because that's what pointer wants. It doesn't want the value. It wants the address of something. and not something really, address of an integer, right? So this is yet another example. Now, things become much more practical in the following example. Let me